Intermediate Algebra for Statistics, Graphing Quadratic Functions in Vertex Form, Part 3. Lesson objectives: find where the quadratic function is increasing and decreasing. Find a quadratic model in vertex form. Lesson objective: Example 12. Where is the blue graph increasing? Here's the vertex at the origin 0, 0, and this part of the graph is increasing. And if you recall, increasing means as x gets larger, y gets larger. Now if we look to the left of the vertex, as x decreases, y increases. So from here all the way to here it's decreasing, and from here to here it's increasing. Now we could write this in set notation. I'm going to write it as an inequality and answer the question. We would say x is greater than 0. Where is the blue graph decreasing? That would be to the left of 0. So we would say as x is less than 0. This function's decreasing. Where is the red graph increasing? We want to go to the vertex. So to the right of the vertex it's increasing. To the left of the vertex it's decreasing. So to answer the question, when x is greater than 3, the red graph is increasing, and the red graph is decreasing when x is less than 3. Example 13. What is the domain, the range? Where is this function increasing, and where is this function decreasing? Number 1, the domain is all real numbers. Every x will have a spot on this graph. What is the range? That's the y values. So since we have a minimum here, these y values below the minimum will not have a spot on this graph. Therefore, they are not in the range. Where is this function increasing? Well, in this case, to the right of the vertex, it's increasing. It's decreasing to the left of the vertex. So the answers are: number 1, all real numbers. Number 2, when f of x is greater than or equal to -2. Where is the function increasing? When x is greater than 1, and decreasing when x is less than 1. Example 14. What is the domain? What is the range? Where is this function increasing? And where is this function decreasing? This parabola is going downward. It has a vertex at -5, 4. The domain, again, is all real numbers. Every x will have a spot on this parabola. For the range, this is a maximum. So all the y values up to the maximum will have a spot on this parabola, but anything above the maximum will not be in the range. So 4 is the largest y. So anything above 4 will not be in the range. Where's this function increasing? This time is to the left of the vertex, and decreasing to the right of the vertex. So the answers are: number 1, all real numbers. Number 2, when f of x is less than or equal to 4. Number 3, when x is less than -5, the function's increasing. And number 4, when x is greater than -5, the function's decreasing. Summary of the vertex form. The graph of y equals a times x minus h squared plus k is the graph y equals a x squared, translated h units horizontally and k units vertically. When h is positive, the graph shifts to the right. When h is negative, the graph shifts to the left. When k is positive, the graph shifts up. When k is negative, the graph shifts down. The vertex is h, k, and the axis of symmetry is the vertical line x equals h. So here we have a visual. H is the amount of the horizontal translation, and k is the amount of the vertical translation. And the vertex is always on the axis of symmetry. Lesson objective: Example 15. The number of flights with taxi-out times of 1 hour or more per 1,000 flights are shown in Table 11 for various years. Let f of t be the number of flights that took 1 hour or more to taxi per 1,000 flights at t years since 2000. Number 1. Find an equation of f. Number 2. What is the vertex of f? What does it mean in this situation? Number 3. Use f to estimate the number of flights that took 1 hour or more to taxi out in 2006. Solution? We can use a graphing calculator to draw the scattergram of the data. So this does look like a quadratic pattern. It's not necessary, but it's convenient to select the lowest point, this one when x is 2 and y is 6.8, to be the vertex. In future videos we will let the calculator compute the vertex for us, but for this example we will use the lowest point. So taking the vertex form, we substitute in our x value of the vertex and the y value. So next we need to find a. So we imagine if it goes through the point 4, 9.7, we can use this t and this f of t value to find variable a. So plugging in our values, we have 9.7, which was f of t, equals a times, this is our t, 4 minus 2 squared plus 6.8. Following the order operation, we subtract, then square. So 2 squared becomes 4. Now we subtract 6.8 to both sides and divide by 4. We see that a, rounded off to 2 decimal places, is 0.73. So our solution is f of t equals 0.73 times the quantity t minus 2 squared plus 6.8. We can use the graphing calculator to verify how well this function models the data. So we hit our y equals, we type in the model in y1, and as we can see, this parabola is modeling the pattern of the data very well. Question 2. The vertex is 2, 6.8, which means when t is 2, or in the year 2002, there were 6.8 flights that took 1 hour or more to taxi per 1,000 flights. Number 3, the year 2006 means t is equal to 6. So using our model, we want to evaluate f when t is 6. So we have 6 minus 2 quantity squared times 0.73 plus 6.8. This gives us a value of 18.48. So about 18.5 flights took 1 hour or more to taxi out per 1,000 flights in the year 2006. Finding a quadratic model in vertex form. Process. To find a quadratic model in vertex form given some data. Number 1, we create a scattergram, or sometimes known as a scatter plot, of the data. Number 2, we imagine that the parabola comes close to or contains the data points and select a point h, k, which is the vertex. Although it's not necessary to select a data point, it is often convenient and satisfactory to do so. Number 3, select a non-vertex point, and it doesn't have to be a data point, of the parabola, and substitute the point's coordinates into the equation. F of x equals a times x minus h squared plus k, and solve for a. And number 4, substitute the result you found for a in step 3 into the function. Thanks for watching.